spotted. And I'm a wizard here, and I'm going to show you the wizardry of client-server applications in TCP/IP. However, first, I need to magically get you an application. So, we have our application, and we have a server. Now, let's see what happens when they start accessing data. Whoa, wow. Pretty fast, don't you think? What? Well, sometimes, of course, we have to access data on a disk, not from the cache, so we'll have to force the data into the disk on the floor. Seems like everything's in the cache right now. Now we have to go back to the disk drive. Slows us down a bit. But you can see how fast everything works. And sometimes every time we have to write, we put them back to the disk drive, eventually. So that's why applications that are actually sat on a server itself run very fast, because we have a cache and we have data. So let's just stop at that point. Now, if you guys are going to spread apart, let's bring in our router. Oh, come on. It takes a long time to configure routers in this building. There we go. Now let's see what happens when we put a router in there for the first client server inside our actual building. So our application is going to start requesting data. So a request goes over. First of all, we have to ACK the request. So we send an ACK back to the application. There we go. There we go. So every request we send has to be ACKed. Now the data goes over. The request for data. And then we ACK the request. Okay, so that every operation we do requires, they're going to keep going, an ACK of the request and an ACK of the data. So that's 4 packets going backwards and forwards on the network. Oops. Whoa, I guess we have a faulty router. He's dropped his packets. I have to send again. Data lost, right? So you have to retry. Sometimes he even drops the axe. Where's the axe going back? Whoops. Sorry. Oops. Whoops. Sorry. I think we got a hardware fault. Anyway, I think that makes the point, right? So let's send the data back. Now let's see what happens when we have a firewall in the way, okay? So now we're going to make the firewall go in the way. So now we have 2 routers, and we have a firewall. So let's see what happens. We're going to request data. Come on, faulty packet. Now we have to send an ACK back. Inspect. Wow, it's slowed down, don't you see? That firewall's got to do a whole lot of work. Now, why did it inspect both ways? Let's just stop a bit there. I mean, the inspecting both ways is probably a firewall configuration problem. I think it should only be inspecting what's coming in if we want to perform. Let's see what happens when we do that. It just speeds everything up.
Oh, that one came in. Shouldn't have been inspected. You misconfigured your firewall.
The inside, now you inspect. The idea is you inspect inbound, not on outbound. Depends if you're in.
Oh, this is a client firewall.
Right.
Oh, okay, I thought this was a server firewall.
We'll have to resend the data. Still inspecting. Doesn't seem to be denying many packets. Not very good firewall. You're supposed to deny some things, right? Anyhow. So I think we can stop at that point and say it shows you just putting a firewall between your web server and your data slows things down. So you have to be careful how much data you put between your different servers and services. So now we're going to show you what happens if we were using prefetch. So if we use prefetch, instead of each piece of data going backwards and forwards, when the application requests data.
I don't have any more requests.
Wow, she ran out. There we go. We got plenty of requests. So when the application requests data, with prefetch, we send a whole amount of data back. Okay. Obviously, the axe would be going backwards and forwards. Now we're going to send a whole one packet inspected, and then we send all of the data back to the application. And that's what prefetch does. So instead of the packets, all of this time frame going, we just sent 10 pieces of data in the same time. It took us to go backwards and forwards for 10 individual pieces of data. The next thing we're going to do is say what happens. This is all inside our building. It's relatively fast. But if you've ever pinged things like Google, you don't know where they are in the world. Google happens to be here and here, so we'll ping San Jose. But however, if you go to Amazon, you could be in Florida. And there's a certain physical amount of time it takes for that packet to go to the client and get ACT. And until it's ACT, we can't then send the data back. So now let's show what happens when the server goes all the way up to Florida. Now, of course, if you're in Oz, you're about 180 milliseconds round trip for every packet. So let's request data after the router. There we go. Oh, you pass it down, pass it back. Going through all the different routers on the internet. Oops, he dropped the packet after sending it again. Faulty router. Let's see if the router works this time. Now, this is going the direct route. Of course, you know the routers can go all the way around. Routers do that. It's whatever the best route is. Now, let's get the ACK come back. We have to send an ACK back. Okay, well, send the blue back as if you're doing it. So now you have to. The ACK comes all the way back across the internet. Oops. Yep. We haven't even got data yet, right, folks? Oops. Yep, going through the route. Okay, gets inspected. Now it sends the data.
But I dropped it.
Okay, if we dropped it, you see the time delay? Now we're going to have the data. The data's on its way back.
Here, Internet, here's my data.
The router jumped out of the building.
Oh, send the data again. Sorry, bad packet. And often on the internet we get bad packets, okay? Which is why there's so much retries go on. Then it goes back through your firewall, and then it goes to the application. So what we've shown here is why things with client server slow down. It's not just simply a matter of our local application with our cache, because though the server is still caching the data, it can't send it out because it has to wait for all the pieces in between. So as fast as that server is, we have to get it to the application. So the more data we can send in one packet, the better. That's what things like sparse selects with the new joins do, because we prefetch and send all amounts of data back and only the records that change. It's also the reason why you should be using XF Server Plus, where effectively you're running a stored procedure on the server, which calculates a certain amount of data, and you only send back the data across all this slowed network that you actually need, or an array of data. But also, when you're on the real World Wide Web, that splits things into packets as well. And because it splits things into packets, you don't want to fill 10 pages worth of data. You want to demand it as a user might need it, so that you optimally can use that whole time delay and the packets as they go around the world. So hopefully that's shown you why client server is something you have to design into your applications, and you have to use the right techniques, because all these things that we've shown you come into play. And that is the wizardry of client server computing.